All right, number 26. The scatter plot shows the number of years of experience. Now, X and the hourly rate pay rate Y for each of the 23 cashiers in Arizona. You really need to read all of this to find out what X is and what Y is in your equation. Okay, or you can look down here. X is the years of experience. Pay is in dollars, which is your Y. Either way, but that's why you have to read it. In any word problem, read so you know what those variables stand for. Okay, so use the equation of line of best fit. So I took a bunch of data. This line pretty much goes through the middle. That's called the line of best fit. Y equals 0.93x plus 7.97 to answer the questions below. Give exact answers, not rounded approximations. What is the predicted hourly pay rate for a cashier with 9 years of experience? Well, the years is our X. Our Y is our money. So here our X is going to be equal to 9. So all you do is you just plug that in. Y equals 0.93 times 9 plus 7.97. So we're going to go to our calculator. Just let the calculator do the work. 0.93, or let's use our store button, okay, just to remind you. So let's do 9 store X and then hit enter. Okay, so now wherever you see an X, it's going to plug in a 9. So we have 0.93x plus 7.97. So it's going to be $16.34. Now, what is the predicted hourly pay rate for a cashier who doesn't have any experience? Well, that means she has 0 experience. Well, when X is 0, whatever you get Y, that's known as your Y-intercept. So it's going to be $7.97, okay? But even if you didn't know that, you just plug 0 in where you see X, and you'll notice that this is going to give us 0 plus 797 gives us $7.97. Or 0 store X, then you bring that back up and you get $7.97. Okay, for an increase of 1 year experience, what is a predicted increase in hourly pay? That would be your average rate of change, or which in this case it happens to be a slope because it's a line. This is your slope. Well, looking here, what is your slope? 0.93. Okay, so again, average rate of change, slope, same thing. All right, now we've got this one here, which is number 27. Okay, for the functions given below, either the function is defined explicitly or the entire graph function is shown. For each, decide whether it is an even function, odd function, or neither. Okay, so even function, they are symmetric to the y-axis. Odd function, they're symmetric to the origin. That is where you have to flip it upside down, which it's kind of odd to do that, so that goes with origin. And then if it's neither of those, it's going to be neither. Okay, so right here, it is down on the left, up on the right. So it's not symmetric to the y-axis because it would have to come over here. In order for it to be symmetric to the y, it would have looked like this. Okay, the left equaled the right, or it looks the same. It mirrored it, I should say. For the origin, you put your pencil in the middle, you turn it upside down, and it looks the exact same as it did to begin with. So that means it's odd. You turn it upside down 180 degrees. Okay, so that's an odd function. Right here, it doesn't, when we talk about it's symmetric to the y, so it's not symmetric here. It's only symmetric like if I had a line coming down like this, but that's not the y-axis. So this one would be neither. Now, had that been moved over, had it been moved over to look like this, something like this, then it would be symmetric to the y, but it wasn't. Okay, so that one was neither. Okay, now they're going to give you a function and you've got to prove whether even or odd. When we talked about this in class, this means you are going to find g of negative x. Here you're going to find h of negative x. Let me put that in red. I probably won't change colors except for this problem, only because on my work I've changed all the colors, if it's a good one. I think it's a pretty good copy of it. Okay, so right here, wherever you see an x, you're going to replace it with a negative x. So you're going to have negative 6 times negative x to the 4th power plus 7 times negative x to the 2nd. So what I'm going to do is take out this x and replace it with a negative x. Okay, now I'm going to do the same thing. I'm not finished with that, but I'm just going to go down here and do the same thing. Negative 2 times whatever x is to the 5th power plus 5 times whatever x is to the 2nd power. And in this case, our x is now going to be negative x. So it is negative 2 times negative x raised to the 5th power plus 5 times negative 2, or negative x raised to the 2nd power. Okay, so now we've got to simplify this. Okay, so when I'm doing this part right here, that's going to give me a positive x to the 4th. Okay, so this is a positive x to the 4th. But then when I multiply it by this negative 6, I'm going to get negative 6x to the 4th. Right here, this is going to give me a positive x squared because I have 2 of them. 2 is even, so it's positive x squared. But then I'm going to multiply it times 7, so I get plus 7x squared. Okay, so and before I talk about even and odd, I'm just going to finish this out. Okay, this one right here, that part is going to give me a negative x to the 5th times negative 2. That gives me a positive 2x to the 5th. Now, this one right here, that part right there is going to give me a positive x squared times 5 gives us plus 5x squared. Okay, so that was the first part to algebraically proving it. Okay, now here's what you're going to do. You're going to compare what we got here with what we had here. These two are what you're going to compare. If they look exactly the same, if all the signs are the same, it's even. If all are different, it's odd. If you have a combination, it's neither. So this was negative 6x to the 4th, so was this. Plus 7x squared plus 7x squared. It's the exact same, so that's even. Because all the signs are the same. Right here, again, we are comparing this answer to this answer. Those are the two things we're looking at. Okay, so this one, the signs are different, so it can't be even. The only thing it could be is odd. Okay, so these are the same. I mean, these are different, but these are the same. It's got to be completely different. This one would have had to become a positive, and that would have had to become a negative. So, but because it was one changed and one didn't, this one would be neither. Okay. So piecewise functions. All right, the thing about this is it's just a function called h of x. We are going to get 4 if the numbers they give us are less than -2. If the numbers are between -2 and 1, you're going to plug it into this and get your answer. If any number is greater than 1, you're going to use this one. So here's what you're going to do. You're first going to look at that part of the piecewise function. In this case, x is 0. That is what this is telling you. It's telling you that x is equal to 0. So what you'll find is you will find that 0 falls right here. 0 is going to fall between -2 and 1. So because of that, we're going to plug 0 in here. So you're going to have negative, wherever you see an x, you're going to plug in 0, plus 1 squared plus 3. Now, this might be easier for you to do on a calculator. I don't need it because what's going to happen is this gives me 1, 1 squared gives me 1, but because of that negative out there, it becomes a -1 plus 3, and we get 2. Now, what you can do on this particular problem is you can take 0, store it under x, and then you can plug in your function right here of negative x plus 1 squared plus 3. And you'll notice that it gives us 2, like we got right here. This here is going to tell us that x is equal to 1. All right, well again, that's going to fall right here because of that equal sign. 1 is between, it is -2 is less than or equal to 1, which is less than or equal to 1. So we're still using this function right here. So again, negative, but now you're going to, wherever you see an x, you're going to plug in 1. Now, oops, I forgot my squared here. This gives me 0. 0 squared is 0. It doesn't matter if you make it negative or positive, it's still going to be 0 plus 3 gives us 3. But again, if you don't understand that, then you're going to have to learn to use your calculator. And seeing I have this in here already, but my x changed to 1, I'm going to put 1 store x, and then all I have to do is bring that back up, and I get -1. Oh, it's that upper level math I can't do. Good thing I did it because I can't do it by hand apparently. This gave me 2. I was thinking this was -1. Sorry about that. Again, I needed you guys here to help me here. This gives me 2 squared, which gives me 4, right? But when I apply this negative to it, I get a -4 plus 3. That gives me -4 here. That's going to give me -1. Good thing I was showing you on my calculator because I don't think I would have caught that. Okay, and then this last one, let me erase this stuff. Now I'm saying that x is equal to 5. So again, I've got to find where 5 fits in. Does it fit in here? No. Here? No. 5 is greater than 1. It fits in here. So that means I'm going to use this function to find my answer. I have 1/4 times 5 plus 2. So that gives me 5/4 plus 2. I think it's going to give us 13/4, but I better check it on my calculator. Okay, 5 store x. Then I'm going to plug in 1/4 x, however it is that you want to do it, plus 2. I'm just plugging that in. It's going to give me a decimal answer right here, but I'm going to change it to a fraction, and I get 13/4. Okay, wow, this review has all this empty space, but oh well. Okay, now use the graph to determine the behavior of the function between the indicated points. Okay, increasing, decreasing, or constant. Okay, between points A and B, the behavior is constant, doesn't go up or down. Oops, that would be between that point, got to get my other post-it note, and that one. See how they just stay? Okay, between B and C, between those 2 points, that decreases because we read it left to right. Between C and D, it increases, and then D to E, it decreases. And it doesn't tell us to give X's or anything like that, so maybe over here. Okay, so we were just recognizing when it increased, decreased, or stayed or constant. I can't talk today. Okay, determine the intervals. Okay, now you got to remember this is X values. Intervals are always our X values. Okay. Determine the intervals on which the function is strictly increasing. So we're just finding, write the answer as intervals or list of intervals. When writing the list of intervals, make sure to separate each interval with a comma and use as few intervals as possible. Okay, so let's talk about this. Again, when you're reading a graph, you work it left to right. You read it from the left and goes to the right. So right here, it is increasing. Okay, now remember, with increasing and decreasing, this has fallen on the floor. It's got all kinds of fuzz on it. Let's do this. No, it won't. Okay, so right here, we're talking about X values only. So between -7, and this is a little crooked, it should be at -4 right there. Okay, it is increasing. And you're going to use parentheses because you can't do 2 movements at once. You can't increase and decrease at the same time. You can't increase and stay constant at the same time. You can't stay constant and decrease at the same time. So it's always going to be parentheses. Okay, so then it decreases, then it stays constant, but then it increases again. Between 2 and 4. So between 2 and 4. And again, because we're doing increasing and decreasing, it doesn't matter if these are filled in or not. It's always going to be parentheses. And it says to separate it with a comma, so we'll separate with a comma. If you put a union, I'm not going to count it wrong. So, okay, right here. Use the graph to find the following: all local minimum values of X and all values at which F is a local minimum. Okay, minimums are valleys. So it looks like we only have one. So it's that point right there. Which is the point? -1, 1. So if it asked for the ordered pair, then you'd put that, or the point at which it happened. But because of this, it wants to know what is that minimum value, which is that 1, and all values at which F has a local minimum, that would be the X value of -1. So this is your Y value, this is your X value. Okay, almost finished, we're getting there. Okay, right here, polynomial function is defined as that. Use your graphing calculator. You're going to have one. That is what we're testing on it. So make sure you have a graphing calculator and know how to use it. Okay, so you have y equals, we're going to take everything out that's in it. We're going to plug this in. -4x raised to the 4th minus 4x raised, I knew I was going to do that. Let's try that again. -4x raised to the 4th. Hit your right arrow key to drop it down. Minus 4x raised to the third. Use that right arrow key to drop it down. Plus 6x squared plus 2x plus 1. Okay, I don't know what zoom I'm in. I'm assuming I'm in zoom 6 because I'm sure I fixed it after the last video. So what I'm going to do is, just to make sure, I'm going to hit my zoom, get my presets, and I'm going to do standard. Okay, use your graphing calculator, let it graph, make sure we don't have to change our window, which we don't. Okay, graphing calculator to find all points x, f of x, that's just x and y, where there's a local maximum, round to the nearest hundredth. Okay, so first of all, if you ever see something written like this, okay, if you couldn't see the maxes on here, because that's what we're finding, then you would have to change your window. All right, so this window goes from -10 to 10, and it's counting by ones. Those are your x values. And then -10 to 10 by ones. Those are your y values. Because sometimes I might have to change this for the test, and I'll write this, okay? And that's where you go in here and change it. But, oops, let's try hitting graph. What that means is there's 10 tick marks this way to -10 to here. We're counting each of these tick marks are 1. Same thing up here and down here. Okay, they're just a little smaller. They're closer together. All right, so we've got to find this point and this point. To find it, you're going to hit your second button, your red, your blue or your yellow button, and you're going to hit trace, which changes it to calculate, because we got to calculate the maximum. We need 4 for maximum. I'm going to find this one first. We need to ask for the left bound. So that cursor needs to be somewhere along this side right here. Someplace. I don't care where. It just needs to be left of that hill. I'm just going to put it right there. Hit enter. Then I'm going to put it on the right side because it asks for the right bound. I don't care if it's here. I don't care if it's here. It can be anywhere to the right of that hill. I'm just going to leave it right there. You will notice that my hill is between my two lines, or between these two arrows. At this point, you can move your cursor up here, or you can just leave it. It does not matter. And it gives us our answer, 100th, okay? Some of you do not know how to round to the 100th. Well, 100 has 2 zeros in it, so this is 2 decimal places, if that will help. The other way is, if you wrote this answer down as -1.264828, because that's what's on my calculator, okay? Because you guys really need to be able to round to the right position. If you put a 1 over the decimal, there's my 10th position, there's my 100th position. This is going to round to -1.26, comma 5.93. That's one of them. Now we're going to do the same thing for this one over here. Second calc 4 for maximum. Oops, I didn't mean to really hit enter, but it's to the left of this hill right here. I just need this to be on the right hand side. I typically put it right in here, but it'll work because it's to the left. Hit enter, putting it on the right, then hit enter again, or you can move it. And notice it went to that point there. So that point, again, we are going to round it 2 decimal places, 0.66, comma 3.02. And there you have it. Okay. Now, I'm going to stop right there.